Hi, I'm Dan. Thank you for choosing Windows 10 devices for your students. We can really make STEM teaching engaging with these devices, which have USB connectivity for probes. You can design and develop 3D objects and connect to 3D printers, and you can do lots of coding and install software, which is used in industry. It'll make STEM teaching really engaging for your students. Today I'm going to help you get started with 3 fun projects using the AdaFruit Circuit Playground Educators Pack. But let's start by unpacking the box. So, inside the case, we have a 3 AA battery holder with switch and a 3 AAA battery holder with switch. We have 2 Circuit Playground Express, a roll of thin copper tape, 1 storage box of batteries, NeoPixels, 2 servo motors, magnets, sewing sequins, extender cable, conductive thread, alligator clips to breadboard adapters, which are really handy if you want to do solder-free breadboard work. There's some alligator to alligator clips and 2 USB micro USB cables. This is the Ada Circuit Playground Express. It has lots of fantastic NeoPixel LEDs on the front, also areas to connect to wearable technology, which you can use with the conductive thread that comes in the pack. You have infrared sensors, you have connectivity, you have a battery holder, you have microphones and speakers, and lots of other cool things that you can do to develop your own projects in the classroom. So there are lots and lots of opportunities to create some great projects which are really fun and engaging for your students, which map to the Australian curriculum from kindergarten to year 12. Today I'm going to show you how to tackle 3 projects at 3 different grade levels using the AdaFruit Circuit Playground Express. And if you'd like to tackle something else, go to our makecode.com website and there's at least 20 great projects to choose from. Every student wants to make magic. With this project, aimed at years 3 and 4, we're going to create a magic wand. This activity comprises of 2 30-minute lessons. One part is making the actual wand, and the other part is actually coding the wand at microsoftmakecode.com. What you're going to need for the actual making part, you're going to need some pipe cleaners of all various funky colors, and you're also going to need something to stick those to, which could be a stick, it could be lollipop sticks, or anything you want. An AdaFruit Circuit Playground Express and a battery holder with 3 batteries in there. Balls and any kind of stickers that you think you need to make your wand look really, really cool and magical. The other thing you might need to do then is use sellotape or some PVA glue to glue these together. Okay, we're going to start by creating the wand itself. I'm using some quite funky coloured lollipop sticks here, but you can use whatever wooden objects you'd like, or metal objects, or rulers, or anything you want. You haven't got to be really fussy about the way you sellotape them together, just to get the wand together. Depends how long you want it. You can get the kids to think about the maths behind it as well if you wanted to. So I'm just going to use those 4 lollipop sticks. Then I'm going to grab some of our fantastic pipe cleaners, and I'm going to go around the wand face with the pipe cleaners. I'm going to use a double back piece of sellotape there, for example, for this one, to stick my little blue star on there. The next thing I want to do is just make sure I've got an area for my Ada Circuit Playground Express at the top, and once that's on, I'm also going to get some sticky plastic and actually make sure that's stuck on properly. Now that's actually going to be held on as well by using some of these pipe cleaners. I'm actually going to stick this through the holes, and these holes are used for wearable devices as well, so you can actually use the conductive thread in the educator pack to create some really cool wearable technology. So hopefully you can still get the gist of what I'm doing here, and you just make it look nice and a bit funky, and connect it in to the actual wand itself at the same time. You make this anything you want and make it look as cool and as funky, and let's move some of these around a little bit. There we go. So there's my wand ready to go and be coded. So that's part 1. Okay, so the next step will be to connect the AdaFruit Circuit Playground to your computer, and let's start coding. Now this is where we do the magic. We start with a forever loop from the loop tray, so the green forever block. We then drag a show animation block in, which is a blue block, which is the blocks that control the lights on the AdaFruit. Now that's going to show an animation, the circles, all of the neopixels around in various colors. I'm going to set the milliseconds, so the actual speed of these, to 500 milliseconds. You can play about and speed it up or slow it down if you want. So that'll loop, as you can see on the left here, the colors going round and round in circles. We're then going to grab a purple block, which is an input block, and we're going to say on shake. So when we shake the wand, so on shake, we're actually going to play a sound, and the sound we want is the magic wand sound. And then we want the animation, which is a blue block, which allows us to change the animation speed to 1500 milliseconds. So we can change that again to whatever we want. Now we've done the magic of the code, we can now save it to the AdaFruit device itself. So I'm going to plug the AdaFruit device into my USB port and then click on download. The pink download button is in the bottom left of the screen. I'm then going to go to save as and save it direct to my AdaFruit device, which has now appeared. And this is the finished wand. Yay! If you've missed any of that, then go onto the makecode.com website and you can see a step-by-step tutorial and go through it at your own pace. Okay, now let's use the pack to create a project for years 6 to 8. Now this project will use the AdaFruit device and allow us to pick a lucky number between 1 to 10. To make this project, we need some cardboard or stiff paper, some marker pens, scissors, and some glue or tape. So with the lucky number, you'd start with some colored card. It's up to you how you want to do this. You could lay this on thick card, or you could actually pick any colors you want. And you actually start to select the size of your circle. So you could link this to your maths lessons if you wanted to, and think about the circumference of a circle and start to bring in diameter. Once you've got your circle there, cut the circle out, and there's one that I've created earlier with a different color piece of card. Then start to cut out some triangle shapes. Now, you probably only need 5 of these, and again, you might want to bring in some maths into play here, and you might want kids to actually measure angles and work out how many pizza slices you'd need in a circle, for example. But then once you've measured them out and cut them out of your green card, like I've done here, or whatever color you'd like to use, then you'd end up with a circle and lots of different pizza shapes. You can see that I've got one that I've already created, and I've put them in position. Sellotape these down, but like I said, you could use sellotape or you could use some cheap PVA glue if you wanted to. Okay, the other thing you could do with this is you could actually start to put in pictures, for example, or students in your class. So it doesn't have to be numbers, but again, you could use this for things like probability. The next thing you have to do is you have to put the AdaFruit in place. We can actually put a piece of double-sided tape or double up a normal side of sticky tape on there. I stick that right in the center, and this is where you'd want to test and line up your neopixels with the numbers. So you can see there's 2 there, there's 2 pointing to the green section, so I might want to just slightly adjust that so it fits in perfectly. The next thing I need to do is connect the power. So I've got my power adapter with batteries already in. The next thing we do is go on to stage 2, which is to code the device. Okay, the lucky number program, we're going to get a little bit more complicated. We're going to first of all get a pink block and specify on shake. So when the device is shaken, then we actually run the code. Then what we're going to do is grab a red set variable block, and we're going to rename the variable to times. Okay, so you can rename it to whatever you want, but actually I'd suggest in my example here, call it something that's linked to the program. Now that's very good to start to get into the process of renaming variables, because it's good for other people to read your code as well. Now I've set a variable here, times, to 0, but I actually want a random number. So I'm now going to grab a purple math block, and I'm going to change the pick random to 0 to 10, okay? So I want to pick a random number from 0 to 10. But actually what I want to do is actually increase that number. So I'm grabbing another maths block, and I'm going to add 50 to that. So actually it's going to pick a random number between 0 to 10, and then it's going to add the number 50 to it. So if it's the number 3, for example, it'll then make it 53. Feel free to play about with some of these numbers as well once you've done the code. We're then going to set a delay, and it's another variable, another red block, a variable block, and I've renamed the variable to the word delay so we can kind of understand what that's actually going to do. I'm going to set that variable to 0. Now what we're going to do is do a loop, and we're going to do a repeat loop this time, and we're going to repeat for the same number that's been generated by the variable at the top, which is times. Okay, so we're going to repeat. So if this has come up with the number 53, it's going to repeat whatever we do in the green block here 53 times. And what we're going to do is move the photon, so that's one of the little LED lights, move forward by -1. So it's actually going to take it anti-clockwise. And then what we're going to do, every time it moves, we're going to actually play a tone. Now what I've done in here, when you bring your play tone block in, which is a red block, one from a music area, instead of playing middle C, so it'll be a little bit boring, I'm going to pick a random number between 0 and 502. So the AdaFruit can play up to 502 different tones. So it's going to pick a random number between 0 and 52. And then it's going to actually play that 0 times and 1 time and 3 times. It's going to go through your little loop. And then we can actually change the delay by 5 each time. Okay, so it's going to start at 0 and then it's going to go up to 5, 10, 15, and the sound is going to go up. So it's going to sound a bit more like a chromatic scale rather than something that's random. Okay, and that is your project done. Now what we can do is press download, plug your AdaFruit into your USB port, and then save your project directly onto the device. If you missed any of this, it's on makecode.com, and the tutorial you can follow at your own speed. In this activity, we're going to create a hot potato. A hot potato is the game where you pass it around until the music stops, and wherever it lands, that's the one that loses or wins, depending on your rules. Creating the hot potato itself takes about 15 minutes, if that, and the coding might take you up to about 45 minutes, depending on your level of experience using block-based coding. What we need is a sheet of paper, scissors, tape, a 1 AdaFruit Circuit Playground Express, battery holder, and some batteries. Okay, the first thing we're going to do is make a holder for the battery pack, because the AdaFruit Circuit Playground Express will stick on top of the hot potato. So we're going to roll up a piece of card and then use some sellotape to secure that together. Okay, so notice I've got the battery pack in there already. And then fold this up. And again, you can make this out of it. You can make this into a rugby ball shape or a cricket ball or just something random like I'm going to do. The next thing I'm going to do is I'm going to cover this with various bits of colourful plastic or paper you might have found somewhere. And then I'm going to double up some of the sellotape and stick that on the top there and secure it down as well a little bit more. Secure the wire down, because don't forget you're going to be throwing this device around. Again, you can sellotape these quite nicely. They're quite hardy devices, so I'm going to secure that down. If you wanted to secure it in another way, then feel free to. And then I'm finally going to secure the battery compartment, just so the battery doesn't fall out. But the fact is that I might want to take the batteries out after I've used the game, and I might want to dismantle it, so I'm going to just sellotape that down and get the wires out of the way as well if I can. Okay, and that is a very, very simple. The hot potato is done. Now let's get coding. Okay, hot potato. This is a little bit more complicated, as there's several different types of loops in here and lots of different variables. So let's start. We're going to start by selecting a pink input block, and that's going to be instigated with the button A clicked. So when you click on button A on the AdaFruit, then the hot potato timer will start. We're going to start off by setting a variable using the red variables block, and we're going to set that variable, and I'm going to call that delay. So I've gone in and renamed the variable to the word delay. And again, get into practice, especially for your older students, to name variables so other students can actually then read the code, and it helps you as a teacher actually go in and decode what they've done and understand and debug any issues. What we're going to do then is drag across some purple blocks, and there's two in here. The delay is going to start at 500 and then go up to a random number, okay, between 0 and 1501. So you can experiment and change those figures if you want, but that's going to be the delay and how long the actual hot potato will actually be in somebody's hands before it goes off. Then what we're going to do is bring a while loop in. Now while loops are really interesting because when you do a while loop, you actually put the condition up front. So as you can see here, we've got while, and then I've put in several different blocks, okay? So you can see that when you start your while block, you have the word true, but actually what we want to drag into here is another logic block which actually sets your delay. So while your delay is greater than 0. So if we go back to the first bit of code here, we've set the delay to 500 and a random number. So it's going to be at least 500 seconds, okay? Or not 500 seconds, but 500 milliseconds. So we've got our delay, so while delay is greater than 0, so that's going to be correct. So while that condition is true, we're actually going to play a tone, which is a middle C. You can change that as well if you wanted to, for a quarter of a beat, okay? But you can change that as well if you wanted to, but I'm just going to set it for a quarter of a beat. And then we're going to show an animation. So this animation is a simple animation that runs through the NeoPixels in a rainbow format for the amount of delay that we have set from a random number at the top. Hope you're still with us. And then what we're going to do is we're going to decrease the value of delay by 50 by using another one of the variable blocks. So you can see here we change the delay to minus 50. So if this delay was 500, it'll go 450, 400, 350, 300, and it'll count down essentially. And once the loop finishes, we then end with another play sound. So actually from our music blocks, play sound, and it's up to you. I put in wah 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 because it sounds as if it's like sad, and then I change the animation on the actual AdaFruit to red and amber, and then I've set that to 2500 milliseconds, but you can change those variables as well. So that's the code done. However, what we want to do is turn the volume up loud. So actually put another loop in on start loop, and then actually set the volume that you want with a slider by using another music block. So I'm just going to set it to something nice like 100. Actually no, let's put it 122. And then my project is now done. I can test the project with the emulator in the top left, or download that straight onto my AdaFruit device. I plug the AdaFruit device into the laptop and then save as. So you might be doing this project for students in year 10 to 12. What you can do is ask the students to edit this code or understand what that code is. You can give them this code and actually ask them to change it and make the game a bit more exciting, or even look at the JavaScript and actually code this themselves in JavaScript. So it's a very, very extensible project, and even though it seems simple, the actual depth of the looping inside there and the use of variables is quite high level and matches to the Australian curriculum. All these projects are fun to do and should really get your students excited about STEM. If you've struggled at any point with any of these videos, go on to makecode.com and go through the tutorials online at your own pace. Happy STEM teaching!